Welcome back to our YouTube channel. If you are new on this channel, do not forget to like, comment and share this video so that it can help the video to go viral and help other people that needs to watch this content. Also, do not forget to subscribe to this YouTube channel. Also, we have some other concepts that we have done concerning different topics as regards science subjects that is already on our YouTube channel. You can also do well to check through our playlist and watch those videos. They are going to bless you. We have talked about different aspects of concepts in science that is going to help you. Back to our concept for today. Today, I want to take you through your Waec chemistry practical for 2026, and I'm going to take my time to take you through likely question that they may ask you in your examination. Now, for this year practical, our sample is lead carbonate and starch. They ask us to mix equal ratio of lead carbonate and starch together. Now, what is the intent of our testing that we are going to be doing for this chemistry practical for this year? We are going to be testing for lead ion, we'll be testing for carbonate ion, and we'll be testing for starch. So this experiment, what our aim and objective is to run through tests that can help us to detect lead ion, to detect carbonate ion, and to test for starch, that if starch is actually starch present in our sample. So this is the test that will be running through in this in your chemistry practical for this year. Now let's go into the concepts fully. Now, first thing is that before you can run a test analysis on a sample, know that your sample must be in aqueous form. So the first thing they will ask you to do is to add water to your test sample. Now, our test sample is the mixture of lead carbonate and starch. So both of them, we have mixed equal ratio of both lead carbonate and starch together. So you can now call it, you can name your sample. Maybe you can name sample A, sample B, sample C. In your exam also, they are going to give your sample a name. So for the purpose of this class, let's call our sample C. So we have sample C plus water. And don't forget that in your exam you'll be using distilled water. Now, if you add water to your test sample, know that your lead carbonate is insoluble in water. Don't forget the solubility, the rules of solubility of salts. All sorts of carbonates are insoluble except that of potassium, sodium and ammonium. Alright, so our lead carbonate is insoluble in water. And you know that actually your starch is also insoluble in water. So if you dissolve this sample C in water, what is going to be our observation? That means that our sample C is going to be insoluble. So our observation it will be C or sample C is insoluble in water. And actually, since our sample C is insoluble in water, this sample is going to, we are going to observe a white solid in that test tube, because the color of them is white. I will say they are insoluble. So we are going to have a white solid. It's also going to be observed, and know that it's also insoluble. So we can also write white solid is observed, because both of them are white and they are insoluble. So you are going to still see a white solid is going to be observed. So what is going to be our inference? our inference is that this our sample is what? Is insoluble. Yeah, our sample is what? Is insoluble. That is going to be our observation. That is that sample C is an insoluble or you say sample C is insoluble. Simple. Sample C is what? Is insoluble. That is going to be our inference. Now let's rule it out. The next likely question that they may ask from you is that they may ask you to add a reagent that is going to make one of these substance in our test sample to be soluble. And the reason why I'm saying that is that if you add any reagent that will make one of your test samples to be soluble, at that point you can now filter. Now the one that is soluble is going to become your filtrate, and the one that is insoluble is going to be your residue, so that you can test for the filtrate aside and you can test for the residue aside. And what we can do at this point is to add acid to our reagent. And if we are adding acid to your reagent, it's going to be affecting your lead carbonate. We are either adding HNO3 or HCl to our lead carbonate. But now if you are adding HNO3 to your test sample, so we still have our sample C. Sample C aqueous. Now it's now in aqueous form because we have added water to it, plus HNO3 plus HNO3. Now let's see what is going to be our observation. We are chemistry students. This is a reaction that is taking place. So let's try to write the reaction. Now the reaction is our lead carbonate plus HNO3. So we are going to have lead nitrate plus CO2 plus H2O. This is going to be a reaction. I know your lead nitrate is is soluble in water. Yeah, because all sorts of nitrates are soluble in water. Now we have gotten our lead nitrate. So that we can now test for lead. Now, but what we are going to see here is that CO2 gas is going to be liberated. And don't forget that I said that we are going to be in our test we are also to test for carbonate ion. And know that anytime CO2 is released, CO2 gas is released, it's coming from an ion, which is CO32 minus, because your CO2 can either come from HCO3 minus or CO32 minus. That means that in the course of this reaction and this lead nitrate is becoming soluble, your CO2 gas is going to be liberated. And that means that your CO2 gas is liberated because this our test sample is containing carbonate ion. That means that at this point we are only testing for carbonate ion by this reaction that is taking place. So two things is taking place when the reaction is taking place. Our lead is becoming soluble now, and our CO2 gas is liberated. That means that carbonate ion is present in that test sample, and that's why CO2 is liberated. So what you are going to see as your observation is that you see this substance, our lead that is insoluble, become soluble. Now the next thing that we are going to see now is that CO2 is going to be liberated. We are going to see an effervescence of a gas, which is CO2, coming out when we are adding this acid to this test sample, because this test sample which is our sample C, contain carbonate ion. So we already have an observation there. So when you add your acid to your test sample, either you are adding HNO3 or HCl, CO2 is going to come out, is going to be liberated. So at this point, what you are going to see as your observation is effervescence of a gas. Effervescence of a And because CO2 is a colorless and what, odorless gas, evanescence of a colorless and odorless gas. Now, two or more gases can have colorless and what, can colorless and odorless. Now, how do we actually confirm that is what is CO2? We pass it to what, lime water. Now evanescence of a colorless and odorless gas, then if you pass it through lime water, it will turn lime water with milky, which turns what, which turns lime water milky. Yeah, if you pass it through what, lime water, it turn what, lime water what, milky. And it's also what, an acidic what, gas. Your CO2 is what, an acidic gas. That means if you also what, pass, if you also test that gas that is coming out, that is what, that is evolving out of the what, of the test tube. If test what, with blue what, litmus paper, it will turn what, blue litmus paper what, red. You can also say which also turns blue litmus paper red. Now here, what is going to be our inference? CO3 2 minus what is present. How do you know? Because of CO2 gas that is evolved out. So we have CO2 gas from CO3 2 minus is present. And here we have tested what CO3 2 minus what already. So what is left for us to test for is what is now what, lead ion and starch. We have to test for what, carbonate what, ion. So here, don't forget, they can ask you to add HNO3 or ACl. If you also add ACl, you still have the same observation here, because we are adding what, an acid. Are you getting me? We are adding an acid. Let's write the reaction. We have our lead carbonate plus ACl. What are you going to have? We have our lead chloride plus CO2 plus H2O. You see that here also CO2 is what? It's also what? Liberated. So you see that they are adding, and they are asking you to add HNO3 or ACl what to your test what? Test sample. Don't forget. But note, if they are adding, if they ask you to add ACl to your test sample, in this place your lead chloride is insoluble. Are you getting me? Your lead chloride is insoluble. So it is actually HCl that you are adding to this place. You know, when we are adding HNO3, we get lead nitrate, and that one is what, is soluble. So we can continue our reaction to test for what, lead ion there, because our lead nitrate is already what, soluble. But if you are adding HCl, your lead chloride is going to what, insoluble. That means you cannot still test for what, your lead there, because it's what, it's still insoluble. So what are you going to do? We are going to eat this reaction. So if it's HCl that you are using here, after you have added your HCl and CO2 is already what, liberated, this your lead chloride is still what, insoluble. So what do they ask you to do? They will ask you to what, to eat it. Are you getting me? They will ask you to eat what, this test sample. And what you are eating is this lead chloride is going to what, is going to become soluble. It's going to what, become soluble. And when it becomes soluble, you know that our test sample contain our lead carbonate and what, starch. Your starch will always remain what, insoluble. So at that point that this lead chloride becomes soluble, after you have heated it, you can now what, filter. And when you filter, your starch is going to become your residue, and your lead that has become what, soluble, become what, your filtrate. Are you getting that? And you are going to do that very fast, because if this lead chloride cools down, you are doing your experiment and you allow your lead chloride to cool down, what will happen is turn back to what, to precipitate. It will become what, insoluble what, again. So it's when you eat it that they now ask you to what, to what? To filter. Then your starch become your residue, and your lead that is coming, your lead has become soluble, so it's going to come out as as your filtrate. But if you use our HNO3, we are going to get lead nitrate, which is already soluble. So at this point, we don't need to eat this one. Do you understand? Because this one already becomes soluble, it becomes our filtrate when we filter, and our starch becomes our residue. Are you getting that? Alright, so you note if it's HCl they are asking you to add to what? Tensable or HNO3. Alright, so that is the clarity between the two. If you are adding HCl, if you are adding HCl or you are adding HNO3. Now at this point now, we have gotten our filtrate and our residue, because after this one we are going to you ask you to filter, and your lead component will be your filtrate, and your starch is going to be your residue. Are you getting that? Yeah, it's going to be your residue. So what we now want to test for is our lead ion in our filtrate and our starch in our residue. Alright, so let's do that. Now let's go for how to test for our lead ion. So we now have our filtrate. You know, I said that our lead becomes soluble if we add HNO3. Our lead becomes soluble straight. If we add HCl, our lead will not become soluble until we heat it. Do you understand? And it becomes soluble, then we filter it, then our lead component become the filtrate, our starch become our residue. So to the filtrate, which is the component that we have our lead inside, plus sodium hydroxide aqueous. Know that our cations is always we test our cation using sodium hydroxide and ammonia solution. Sodium hydroxide solution and ammonia solution. Those are the reagents that we used to test for cations. So when you are adding this substance to any of your sample, you know you are testing for the cations. So plus filtrate, what you are going to see as your observation is white precipitate. If you add your sodium hydroxide to a test sample that contains lead ion, your observation is going to be white precipitate, and our effect will be lead 2 ion is present. That is in drop. Then when you add in excess, don't forget to rule it, plus in excess. If you add in excess, the white precipitate is going to dissolve. Then we have white precipitates dissolves to form colorless solution. Now if you add your sodium hydroxide aqueous in excess, we are going to see our white precipitate is going to dissolve to form a colorless solution. This is also an inference for lead ion. It's still lead ion that is present. Now what next thing they will ask you to add? They will ask you to add to add ammonia solution in drop and in excess. Ammonia solution in drop and in excess. So we still have our filtrates plus ammonia aqueous in drop. Our observation will still be white precipitates. And our inference will still be lead 2 plus is present. What is next thing they ask you to do? To add in excess. We add in excess plus in excess. If you add in excess, your precipitate will still remain insoluble. Precipitates insoluble. Now this observation that we have for our lead when you are adding ammonia in drop and in excess is the same observation that we always have when we are talking about lead ion and what and aluminium ion. Aluminium ion and lead ion always have this what this observation when you are adding ammonia in drop and in excess. But since we know that is lead that is in our test sample, we know that what our observation here is mainly for what lead ion and not aluminium ion. So here we still have our lead 2 ion is present. Do you understand? Our lead 2 ion is what is present. Now let's test for the remaining thing that we want to test for here is what is starch, and that is the last aspect of this work that we are doing today. So that will be our residue plus iodine. So the reagent that we used to use to test for starch is what is iodine. So to your residue, you ask you to add what iodine to your test sample. And if you add iodine to your residue which contains starch, our observation is going to what is going to be blue black coloration is observed. That is going to be our observation, and this observation is peculiar to what to starch. So what is going to be our inference? Starch is present, because this color blue black coloration is peculiar to what to starch. And this has bring us to the end of this what of this color separation. That is all that has to do with what the qualitative aspect of Waec chemistry practical for 2026. I believe that you understand this concept very well. If you have anything that you want me to make to enlighten more for you concerning this practical, do well to drop in your comment section and I will respond to your message. Do not forget to like this video, comment to let us know how well we have done in this video, and do not forget to share with your friends. And lastly, do not forget to subscribe to this YouTube channel. That is the only way you can use to help us in this channel. And watch out for other videos that we are going to do concerning volumetric analysis. I'm going to do that aspect also. Watch out for it, and watch out for other content concerning science concept that we are going to be dropping on this YouTube channel. Thank you.